Hello and welcome to my channel once again. Today we are looking at classes. Just like I promised the other time that we will look at classes when we were presenting on structures there to show how they are related concepts. Whereas classes are a concept that is fundamental to OOP, and we are going to be using Python today. So without much ado, let's head over to VS Code there and start with our presentation. Okay, so what will be happening today is simple. This let's put our head there, Python 3. Okay, we are going to have classes. It's a class that I'll call my family. We use a camel case as a convention to define when we are labeling our classes, and we initialize a class with the init constructor there, and we include parameters here. Well, like I defined structures the other time as a record for whatever attributes that you come up with. The same thing applies to classes. They are a record. In this case, I am recording members of my family, the parameters. So let's go on with that. Let's say Spa, Anita, Liam, Amu. Okay, I'll put in 4 members there. Then I'll go on and initialize with the self there. Self dot Anita. Yeah, forgot to it. Anita equals Anita. Anita there. We'll do the same thing for all of these parameters that we listed there. Okay, now we will create what we call an instance of the class my family there. Let's call this instance family, instance of the family there, with which we will access the members of the family. We can say instance family, my family there, and then we can now define the parameters that we can now assign values to them. Okay, let's say that we are listing their ages here. Let's say if Spa equals 12, Anita equals 8, Liam equals 2, Amu equals 2, like that. Okay, and we can go ahead and print the members of the family. This is Spa Sparse age, sparse age. Okay, like that. We instance family. We use the dot operator there to access Spa, like that, the same way we did with the structures that we're presenting. But here we are going to show how invaluable classes are as a concept in that they allow for extension of the base class using what we call inheritance. So with this we mean that the my family class here is a parent class, from whence we can define another class that borrows from this my family and in effect extends the my family class to have other attributes that we didn't include here. In this instance, I'm going to say we will extend my family class to have extended or family friends. Let's have a class that we call class family friends. Family friends, like that. That borrows from my family, and my family goes in here is now a parameter. My family, my family, like that. And then we go ahead and initialize just like we did with that one with the constructor there. We say self, then we go ahead and list all those attributes that we had there and more, and new parameters that extend the my family class as we would like to have. Okay, let's say that we are going to include the FMB here as a parameter and NetBank as the other parameter there. These are going to extend my family there. Alright, so what happens here is now I'm saying that I'm defining another class here that is called family friends, and I've initialized the attributes here, some of which contain those that but I have not given official communication to this my family class here, other than including the my family parameter there, which in effect will cause issues if I don't include the positional arguments there. Okay, so what I'll do here is I will include only those attributes that belong to the parent class. How many are there? We've got 4, like spa, you got Anita there, we've got Liam, and we've got okay, we're now acknowledging the parent class and saying, okay, we are borrowing your attributes here down below. Okay, so let me define these ones. We are initializing them, I mean, that we had not done, like that. NetBank equals NetBank. Okay, that's what we are doing here. Now, just like we did with that one, we can instantiate here with an object. Let's save ours. Let's just say object family. Let's just say object. I don't want to have a longer name when I'm trying to instantiate that with the dot to cause a problem. So it's object equals family friends. Family friends there. Okay, with all the parameters that I included there. Once you leave out any and they don't match, we are going to have positional arguments issue. So it's like a format. They must be formatted in the correct manner. So spa, let me define a spa as a. Now the good part about this is that I can extend on this one and define sparse age differently. Now I can say sparse age equals 24, and then Anita I can come up with say 13. Liam I can say equals to 12, and Amo let's say equals to 9. Okay, and this will not affect the parent class because it's being done on a derivative of the parent class. That's the cool part of object-oriented programming. We're extending now on my family class without affecting the class, the initial class where we defined it. Okay, now let's just print sparse age again. Okay, like that, just like we did. Okay, so let's say object object dot spar, right? Damn it, like that. All right, so what do we expect to happen here? We expect that it will print a different age now other than that one. All right, so we're reassigning a sparse age in this subclass of family friends there. Okay, seems like there are no issues, so let's go ahead and see. Let's run this one. Okay, what do we have here? It says that missing 2 arguments. Okay, yeah, for sure, that's what I was talking about. All right, I'd forgotten to include the FNB there. It's very crucial that we don't forget these things to avoid conflicts there. Now when I'm compiling, the compiler is surprised that you had defined your record as this, and now you want to search it this other way that we don't know of. Okay, net bank, let's say it's a former bank, former bank of ours. Okay, all right, like that. Let me say former bank. All right, I think it will print out now without any issues. Okay, but like I said, sparse age is now being reassigned now with this new class there. But that's not the point that we have to see that we have extended on the my family class there to include other parameters that we did not include there, like our bank issues, our bank details there, that we bank with the FNB. Formerly we used to bank with NetBank. Okay, with that said, let me just go ahead and say print our bank. All right, then we say object dot FNB. all right, like that. It has to print that we are banking with the FNB, our bank there. Okay, our bank is our bank. Okay, but then let's say FNB. No problem. To demonstrate that we are building on what we defined previously. So our bank is FNB, but we have extended on what we initially had. Maybe he has gone up now, is now 24, he was 12. It just shows a code reusability and flexibility, as we have shown. So without much ado, let's head over